So for example number 4, let me read it to you and then we'll draw the picture. It says, designing a running track. The running lanes at Emory Sears Track at Bluffton College are 1 meter wide, and the inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 3? So let's there's a picture in the book, so I'll just draw it out for you guys. We kind of have something that looks like this, where you have lane number 1 and lane number 2. And what they're saying is that from here to here, 33 meters, and then from here to here, it's 34 meters. Okay? And so let's read this again. It says the running lanes at this track, the first lane has a radius of 33 meters, and the second one has a radius of 34 meters, and they're 1 meter wide, obviously. And, oh, I did not draw this picture exactly the way it should be. This is to the inside of the track. So from here to here, it's 1 meter, and from here to here, it's 1 meter. Okay, does that make sense? And so what they're asking is how much longer is lane 2 than lane 1? And so if you've ever run on a track, how many of you guys have participated in track? Okay, a couple of you guys. You know, you run the same length. You notice that when you start in different positions, but then you finish all at the same point. And that's because the outer lanes, it's not that you run more, but you do kind of. And the inner lanes, you don't run as much based on the curvature of the lane. And so that's what we're trying to determine. Like, how do they know where to position you? So you run exactly the same amount. And so what we want to do for this, to find the solution to this, is that we have to remember that S is equal to R times theta, and remember that theta has to be in radians. And so each lane is a semicircle, so it's 1/2 of a circle. And so what does this measure from here to here? In other words, if I go from here all the way to here, what does that measure for theta in radians? Now you might be confused, but if I draw the xy plane on top of our picture, like this, where this is the x-axis and this is the y-axis, what is theta? How far am I turning around that turn? Say it. Oh, you guys are a little timid. It's first thing in the morning. 180 degrees, but in radians, what is 180 degrees? Pi, right? So theta then would be pi, okay? And so to find the difference, what I'm going to do is I have to measure the arc length, right? So my arc length S is going to be this arc length, and then I'm going to compare that to this arc length and find the difference between the two. Now I could do that all in one, the first arc length, or let's do the second one, it's just going to be the radius, which is 34 pi, and then if I want to do the other arc length, it's 33 pi. So to find the difference between the two, what do I do?
34 pi minus 33 pi.
Yeah, that's exactly right. I'm going to say 34 pi minus 33 pi, which is just pi. So now what does that tell you? How much longer is lane 2 than lane 1? 3.14 meters, right? So if I were to write this in regular English, I would say lane 2 is 3.14 meters longer than lane 1. Does that make sense?